Question number 4. The graph below shows the straight line PQ. So the graph below shows the straight line PQ. Find the gradient of PQ. Well, to determine the gradient of PQ, I need the coordinates of 2 points on the line. I guess we could use P and Q. P is the point -2, -3, and Q is the point 3, 7. The gradient M of PQ would be equal to y2 minus y1 over x2 minus x1. So it would be 7 minus 3 minus 3. So that's 7 minus 3 over 3 minus 2. So this would be 10 over 5. The gradient of PQ is 2. Write down the equation of the line through P and Q in the form y is equal to mx plus c. Now, for the equation of the line, I need the gradient m, which we know is 2. And c, we can get from inspection. C is the y-intercept. So this would be c. And it's clear that the y-intercept c is equal to 1. So the equation of the line PQ is the line y is equal to 2x plus c, which is 1. Two functions f and g are defined as f of x is equal to x squared minus 1. G of x is equal to 3x plus 2. We're asked to find I, g of minus 6. All right, so g of x is equal to 3x plus 2. G of minus 6 is saying in G, wherever I see x, I must put minus 6. 3 times minus 6 is minus 18. Minus 18 plus 2 is minus 16. If the signs are different, subtract and keep the sign of the larger number. We're to find the inverse function, f g inverse of x. So g of x is 3x plus 2. First step, y is equal to 3x plus 2. Second step is to interchange x and y. Wherever you see x, put y. Wherever you see y, put x. The third step is to make y the subject. So positive 2 on the left goes on the right, goes over to the left and become negative 2. Next, I'm going to divide both sides by 3. And when I do that, I'm going to end up with y is equal to x minus 2 over 3. Now, the fourth and final step is to say g inverse of x is equal to x minus 2 over 3. Next, we're to show that just waiting a little. So next we're to show that f of g of x is equal to 3 into 3x plus 1 multiplied by x plus 1. All right, first of all, f of g of x is a composite function. So literally, to form this composite function, I'm going to put the function g inside of the function f. Here's how it works. I'm going to write the f function, which is x squared minus 1. And in f, wherever I see x, I'm going to put g, and g is 3x plus 2. Let me just double check. Yes. So let's simplify. This becomes 3x plus 2 times 3x plus 2. 3 times 3x is 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. 2 times 2 is 4 minus 1. Now we have 9x squared plus 12x plus 3. Immediately I can see that 3 is a common factor. 3 into 3x squared into 9x squared is 3x squared. 3 into 12x is 4x. And 3 into 3 is 1. So to finish, to get my answer, I need to factorize 3x squared plus 4x plus 1. Using the ABC method, AC is 3 times 1, which is 3, and B is 4. To factorize, I need two numbers. When I multiply them together, I get 3. And when I add them together, I get 4. Those two numbers are 3 and 1. 3 times 1 is 3, and 3 plus 1 is 4. So now I have 3 into 3x squared plus x plus 3x plus 1. The 3. Now over to the left. Over to the left, x is common. X into 3x squared is 3x. X into x is 1. Over to the right, 1 is common. 1 into 3x is 3x. 1 into 1 is 1. This becomes 3 into 3x plus 1 is common. Multiply by x plus 1 in the next bracket. And so this works out to be 3 into 3x plus 1 multiplied by x plus 1. Next, we're to solve. F of g of x is equal to 0. So that would be 3 into 3x plus 1 times x plus 1 is equal to 0. So now I'm multiplying 3 things and I'm getting 0. It is clear that 3 is not 0. So if 3 is not 0, it means that it is either 3x plus 1 that is equal to 0 or x plus 1 that is equal to 0. 3x would be equal to minus 1 or x would be equal to minus 1. Over to the left, if I divide both sides by 3, I'm going to end up with x is equal to minus 1/3 or x is equal to minus 1. Whenever we solve a quadratic equation, we must get two answers.